Thanks for having me here, Seth, and nice to meet you all. Appreciate you joining us in this discussion. I'm excited to tell you a little bit about the work that we do here at Lexion. We are an NLP first company, so I think it's very relevant. I wanted to cover a lot of material, so I'm mostly going to keep it a little high level as I go through the presentation. But towards the end, I'm going to leave ample time for a Q&A, and I'd be happy to go back into any slide that you want to go deeper on and talk about more of the specifics and details. So please, feel free to take notes, and then we can go on and discuss them in detail. And I'm going to start by sharing my screen. And go into slideshow mode. Can people just confirm in chat or?
Looks good.
Okay, fantastic. Cool. So a very quick introduction about myself and the company. So my name is Emad Elwany. Prior to Lexion, I was at Microsoft Research working as an engineer and an NLP researcher. I worked on multiple NLP products there. If people might be familiar with some of them, like Lewis, their language understanding service, as well as Pod Framework, their conversational AI platform, Cortana, in particular, their assistant, but in particular, the scheduling component of that. So a lot of NLP work there. I went to grad school at Stanford doing computer science. I wanted to get into startups, so I left Microsoft and didn't want to take too big of a leap doing a company out of a garage. So instead, I opted to join an incubator. And the Paul Allen Institute for AI had a really excellent incubation program for NLP-focused startups. So I joined there in 2018. It was a really nice segue from big company to startup land. And over there, I met my co-founders, James and Gaurav, and we co-founded the company together. For those who don't know it, the Paul Allen Institute is a research institute here, funded by the late Paul Allen. It it's very focused on AI, but in particular NLP. They're the creators of things like Allen NLP, Aristo, and a lot of projects in that space. At the time when I joined, the Elmo paper had literally just come out, and a few weeks later, BERT had come out. So there was a lot of excitement about what's possible. During my time at Microsoft, there was a lot of work there that I did and others did in the industry around short text. Everybody was applying NLP to chat scenarios, customer reviews, customer support tickets. It went as far as long as maybe a Wikipedia article or a news article. There was very little work done in really long documents. Think a few pages or even 100-page document. And because of the work, because of the contextual embeddings and kind of the boost that they gave and all the work that happened in transfer learning, we were interested to try to see how far we can go now in long-form documents. Not only because of the Elmo and Bert and their cousins, but also there was some really exciting work coming out of Stanford. I'm pretty sure a lot of people here are familiar with it, which is the weak supervision movement and the deep dive project. So we really wanted to combine these two things to solve, or actually ask the question, can we now extract information accurately from really long documents? And can we use weak supervision to annotate massive data sets that are very long without spending too much money on annotation? So the answer turned out to be yes. And very quickly, we'll build this NLP platform, but we also launched a product on top of it that was in the early days focused on contracts. We tested this platform on many domains. We found success in multiple ones, but in contracts, it was very clear that there's real value and that we can build a very successful business. That was circa 2019. As we evolved, we started growing out of legal and doing a lot more, and I'm going to touch about that later in the talk. I just want to give a very brief overview on just that NLP and legal tech are just such a good fit. At the heart of legal, there's so much text information. So both NLU and NLG, understanding and generation, you can go from, in litigation, there's applications for e-discovery. How does a lawyer presented with millions of pages of evidence, quickly can they find relevant information to the case they're working on? And how can they go and search in case law databases to find similar cases? These are really hard problems, and they're very well suited for NLP. And NLP companies are adding value in this domain. Same for law firms and knowledge management. Big law firms manage so many clients across so many departments, and lawyers come and go, paralegals come and go. How do you actually maintain this knowledge over time? This is not particular to law firms. It's a problem that happens in any large organization, but there has been a big wave of legal tech companies that are solving this problem. And then intellectual property is another big area where NLP is applied successfully because of patents, understanding what's in a patent, being able to do the patent process itself, like responding to government queries, or sorry, the patent office queries quickly and effectively and without paying too much money has also been another area. But, and there's many more, but the one I'll focus on and where Lexion focuses is contract lifecycle management. Essentially, how do you apply NLP to the contracting process end to end? And just because I would guess that most people here are not very familiar with contract lifecycle management, it's not a very exciting topic, but it is to me now. I want to just to give a brief overview. What really is contract lifecycle? A contract starts with a draft. Somebody drafts an agreement, typically from a template, sometimes from scratch. It is often reviewed because a lot of people have to sign off and make sure there's no risk or that the business terms are acceptable, the legal terms are acceptable, etc. It's often negotiated back and forth with one or more counterparty. And that's what we call the pre-execution or the pre-signature phase. And NLP can do a lot in this phase. Then signing happens. It's not very eventful. But after it's signed, there's still a lot of work where NLP can help. You still need to understand all the terms you agree to and track them. You want to be able to report on them and find it. So if you, for example, want to just run a report and find, hey, which of my agreements have that specific right or that specific obligation? If you don't have good structured data for your contracts, which most companies don't, it's really hard to operationalize these contracts. And in doing that, or in not doing that, you expose the company to a lot of risk in meeting its obligations or enforcing its rights. And then at some point, a contract ends and you want to get into the next incarnation of it. So you can renew it, you can terminate it, you can create a new version with different terms and so forth. This is what we call the life cycle. And this signing space really will divide it into pre-execution or pre-signing and then post-execution. And this is why I'm re-emphasizing this these two sides will become relevant as I talk about the NLP tasks. So let's talk first about post-execution or post-signature. And I'll start there because this is where Lexion started. In post-execution, the thing that Lexion built and helps with is taking a very long document, being able to quickly extract structured information. So if you have, let's say, a 50-page contract, customers really don't want to read it over and over and try to find it or type in the data manually. They would love to have a system that just reads it for them and then tells them all the information about it. Who are the parties? When is it effective? What type of contract is it? What are the insurance amounts that are required? Are there indemnity rights? I have a simple example here from our product UI that tells you what's the life cycle of the contract. Is it a fixed term? Does it auto renew? How long is it for? If it renews for how many times? How much time do you have to cancel? When is the actual deadline for cancellation? These are very important things for effectively operationalizing the contract. And today, Lexion extracts more than 120 such terms very quickly. So you essentially upload a new contract coming from your signature system or via email, or just manually upload it, and these fields pop up really quickly. And I'll start by switching to a demo, really to make it a lot more clear. So I'll just get out of presentation mode and switch to the Lexion UI. Put this out of the way. So here I am in Lexion. I'm just going to open a contract that was recently uploaded earlier this day by one of our member of our sales team. I'm going to orient you very quickly. You can see here, this is the PDF of the contract itself. It's a master services agreement. It's an 11-page contract. But as you see, in a couple of minutes after this was uploaded to the system, Lexion already started extracting information. It tells you what kind of contract it is, what its title. Looks like it's a contract between DocuSmart and Dunder Mifflin. It has that effective date. It expires on that date, which we auto-computed. So how did we compute it? We actually read this text and understood that the term is fixed and that there's an initial term of 1 year, and then it automatically renews by reading this language. And it's really nuanced. So there's like two parts of the text that say 1 year, but they mean different things. In one case, it's the initial term, and the other one is the renewal period. So the models have to be sophisticated enough to delineate these concepts. And then it does a lot of these extractions, and at the end of the day, is able to compute for you this expiration date and that the contract is actually active because it expires in 2023, in June of this year. Similar things around a lot of other terms. We have just a sample of these models of our menu of models here. But depending on the use case, customers would opt to add a lot more to their various document types. Like payment terms is how much do I have to pay an invoice? Can my vendor charge me late payment fees? And then we also extract what we call clauses. So these are just talking about a concept and not just a piece of structured information. They're very valuable for lawyers. For example, when the pandemic happened, all lawyers and all companies now are very interested in this force majeure clause. They typically never really cared about it, but it's now very applicable. And now I have a portfolio as a lawyer of 10,000 contracts. I want to see the force majeure clause in each one of them. So Lexion can help with that. And we extract a lot of these, and they're fairly accurate, and this allows customers to build trust. The second piece of this puzzle is not just the extraction, which is where the NLP shines, but now that I have the structured information, I can very easily create a report. So I can come and say, hey, you know what? I want to see all maybe term type, all other renewing agreements. And then looks like I don't have, so we'll just say fixed. And I want to see only focus on ones that are vendor agreements or any other term that I want, or maybe ones that mention customer data. So now very quickly, I'm able to slice and dice my data and get to the relevant contracts very quickly. And I can start seeing the clauses or the thing that I'm searching for on top of the structured information. I'll switch back to my presentation now and then talk about the NLP, which I think everybody here is more excited to learn more about. So what really is contract understanding as an NLP task? It starts with an input of a PDF. And then first step is we have to run OCR. And a lot of time people think of OCR as just text extraction. It's really not just that. You have to extract text. You have to extract a lot of visual information about layout, structure, font styles, text placement. And there's also a lot of structured data because these contracts do have tables. And then there's a lot of models. There's a network of models in the middle that does things from detecting agreement boundaries, detecting headers and footers, classifying different chunks of the document so that we can run the relevant models on top of them. There's a lot of models in this step. And towards the end of this network, you have your typical NER models, entity extractors, classifiers, and relationship extractors. And there's typically a very thin layer of business logic, just because the customer is not really interested in just seeing the effective date and the contract length. They actually want you to put these two together and tell them that here's the expiration date. So this is what I call the logic layer. And then for the rest of this talk, I'm going to go deeper into various problems that we have faced and solved in this task. So first problem is PDFs are very non-friendly format. It's a very non-friendly format for NLP. They're messy. They're not structured. There's images, and the OCR step itself has a lot of errors that you have to correct for. We approached this problem thinking that OCR is solved and learned very quickly that it's so far from being fully solved. So we had to do a lot of fine-tuning at that step itself. The contracts themselves are very long. They're typically, the file has multiple contracts within. So most in the wild, you would find maybe a master services agreement, 2 exhibits, an addendum, maybe a DPA, like a bunch of other contracts. And often they will have conflicting information. So maybe the master service agreement has a fixed term, but the addendum about privacy has a perpetual one. So now the model will get confused. How do you help it with that? Then the third point is contracts written in very specific legalese, and it's not the English we use in day-to-day. You're going to start seeing words like witnesseth and henceforth and thereof, and most models are not really trained on this. So you have to really solve that issue. The schema itself is very complex. I gave you a very simple example, with just to detect that a contract is active, you have to piece together these 6 or 7 pieces of information. And this is for the simplest case. Once you get into more complex stuff, especially around indemnity, liability, you have to piece together a lot of information. Assignment is a very typical concept that's very important in commercial contracts. And to get who can assign a contract to who has the right, in which direction, very complex. And then the last one I want to touch on is that the contract themselves are a mix of unstructured and structured data. You will have prose and just text in paragraphs, but you will have nested within tables that reference the text and vice versa. And the tables are often not just your very nice vanilla like rows and columns. They would often be nested tables within tables. You would have cell merges. You would have headers that are truncated by page boundaries. So you lost context. And you, again, have to solve for these issues. On this chart, I just one of a paper that we published in KDD, we wanted to quantify how this length issue makes it harder. And you can see there's a very fast drop off. The longer the contract gets, the accuracy and F1 score go very low very quickly. So you have to kind of like keep it up or figure out a way to chunk the document and run these models effectively. I'm going to talk about a different problem now, which is there's too much data to annotate. First, there's so many contracts. We have millions of contracts in our system now. And then every contract itself is very long. You cannot really have a team of annotators effectively go and create any sort of like reasonably sized data set because they're really searching for a needle in the haystack. So what have we done? We solved it with two ways. The first one on the slide is what I mentioned to, relying on weak supervision. Our annotation team does not actually do manual annotation. Instead, they write labeling functions, and these labeling functions will get applied to thousands and often annotate so much data in one swoop. And then we have a system that will help us kind of understand these labeling functions are never going to be perfect. Maybe if they're going to be correct 80, 90% of the time. So you have to have a weak supervision system that helps you select the correct ones. We only involve humans in two cases: when we're building ground truth data set, let's say for held out evaluation or for dev evaluation. So we want it to be perfect. So there we do all the usual things. We have a team of annotators do it, and we have people double check it. But this is a much smaller data set, less than 1% of our training data. So labeling functions is the approach we've taken here. We've published a paper also in KDD a couple of years ago, talking about how effective this approach with a company called UiPath. It's an RPA company, had a use case where they had a pile of really long documents. They gave us 200 and want to extract 8 things. So we just used our stack to, within 1 week, build 8 models with a very high accuracy. I think the average was 94%, taking advantage of that our annotation team was able to very quickly annotate the data, and our NLP models themselves were powerful enough to solve the issue. All the papers I'm going to reference, by the way, are on our website. So you can go to Lexion.ai, the artificial intelligence section. You're going to find a list of all our published work. The second part of too much data to annotate is that even an annotator, when they're trying to pick, okay, what patterns do I write a labeling function for, or even hand annotate? It's too hard to decide. It's unreasonable to ask. So what we do is we help them. So the system proposes or gives them suggestions on what to annotate next, and it tries to guide them to the ones that will add the highest value. Active learning is very good at this. Obviously, it has its own downsides. It's not a perfect system, but it helps with exposing data that are high value. So we would flag things that we predicted incorrectly, or that we predicted correctly, but it was too close to the decision boundary. And it's kind of obvious in our view, so we want to push it further from the decision boundary. We also try to flag underrepresented samples, so something that looks very different from the rest of the data set, because we don't want to overfit to like the more common patterns. And then also it's a way for us to review customer corrections. Every single contract we run AI on, the customer has an opportunity to see where the data came from and to correct it. And all these corrections flow into our training system. We cannot add them directly to our training data because, first of all, the customer might be wrong. Second of all, they might be right, but we might disagree with them on the ontology. So maybe they view something as a certain value. Maybe they think this is perpetual language, but we think it's actually fixed term. And we want to stick to our ontology. We still want to flag it and like fix it for the customer, but we don't want to impact all other customers if there's a more generic agreement. So this system allows our annotation team to kind of hunt for these data and annotate very quickly. They literally annotate thousands of documents every week across a very large suite of models. I'm going to shift to a different problem, which is annotation for long-form documents. When we started in 2018, there were very few tools that are good on long. Like they all were very poor and expect you to work on shorter text. We at the time we didn't find anything, so we built ones. We couldn't find a tool that allows you to do multiple models at the same time, or do relationship, or do kind of highlight conflicts. Also, we didn't find anything that works well enough on PDFs. And annotation on PDFs is important because the visual layout of the document will help the annotator get the right answer faster. So we ended up building this tool. it helped us with this UiPath project and our core products. We also built a lot of custom models for like a specific law firm, for example. Often one of our bigger customers will come and tell us, hey, I want this thing that's not part of our menu. So this system allows us to do it quickly. And we're always searching for more. If anybody has a need for any such platform, we're always looking for partners who would find value out of this system and looking for ways to partner and make it available to them. So please drop me an email if this is of interest. One problem I alluded to earlier is just how noisy. So I said that the PDFs are messy. How messy are they? They're sometimes very old documents from the 90s and 80s that are just really poorly scanned. Sometimes the pages are skewed. Sometimes there's coffee stains. There's often scribbling and handwriting, and sometimes just text is struck out. And sometimes the text is just overlaid. And let's say the DocuSign signature block can hide a very critical piece of information, like what's the date or who's the counterparty. So you have to kind of understand the layers in the PDF itself. Tables are complex. I already mentioned that. And then this one is really painful. We solved it very early on because it was impossible to make progress without solving it, which is the text is interrupted by page headers, page footers, logos, images, multi-column format. You have to really get the text in the right flow and remove these interruptions. Otherwise, your model will get an incomplete context to be able to do the task correctly. So we built early on a system that will just take your long document, identify each part of it. Oh, this is a header, this is a footer, this is a logo, etc. And then try to stitch the text of the prose that you want to run the NLU on correctly first, so that you don't have to deal with these issues. Related to that is we have also found that you can't treat it as just text. There's so much richness. Where the text is on the page, is it close to the page beginning or the page end? Is it close to the margin? Is it centered in the document? Is it indented? This layout has so much value. Also, is it styled? Like, is it bolded? Is it underlined? Did the font change from this part to the next one? This styling information is important. And then visual grouping, like which parts of the text are together or seem part of a similar bulleted list or the same paragraph or the same page versus some others that have some visual delineation. So we went and published this paper also, I think it was KDD, on how impactful these visual cues are and critical to actually squeeze every bit of accuracy. And we found them to be substantial. So it varies depending on the task. We picked 4 of our tasks to run this experiment on, but the results are largely unchanged for most of our models, that you have to use these visual cues to be able to solve the problem. And it's not an NLP task, it's an NLP plus computer vision task. And there's been a lot of research in the recent years. I think starting, I remember the Grid-BERT paper, but there's many more that happened after that. And multimodal models are becoming very popular now in the recent months. So I do think that people should really think of these tasks more as NLP plus computer vision task and try to build as much as they could of the pipeline into shared models to get more value. One more problem that's particular to our domain and many domains, but lawyers are really nitpicky, and just it's part of their training that they have to be very detail oriented and not miss any small thing, and they want high accuracy. So they have really high F1 score demands. They do not trust the system if it drops beyond a certain point. We have found empirically that this seems to be in the 90 to 95% F1 score, 0.9 to 0.95, with favoring recall over precision. If it's less than that, they just give up and like they're like, okay, this is not good. I'm not gonna trust it. I'm gonna have to do it anyway. And then so the goal post is really high with a challenging problem. And then we also learned that they care really more about recall than precision. Why? It's simple. It's a very long document. Think like 50 pages. If you give them the wrong answer, they can quickly find out that it's wrong because you give them the extraction and where it came from, and any lawyer will be able to detect that. But if you don't give them, now they have to wonder, is it there or is it not? Now I have to go read the whole thing. It's kind of like P equal MP, where like you can easily verify the solution in polynomial time, but it's really hard. Like it's not proven if you can actually get the solution in polynomial time. So we've really skewed all our system to favor recall over precision. You can't go too far because if you're always giving for precision, then again, it doesn't help, but that was just a key learning for us. And then I think the last thing I want to touch on, not surprise to anybody in the room, I'm sure, but it's really like large amounts of high quality data is just so critical. And in the early days, we tried to get our hands on as many contracts as we could from public data sets. Once we went to market with the initial set of models, we found that they're not performing as well. They're not very realistic. They look slightly different. There's a little bit of drift. So we invested a lot in getting high quality data, and it took us a few months to build a data set. And we were actually curious how much of a competitive advantage is that data set. And even when we talk to our investors, like, is this part of our moat? And we published this paper in a conference also a few years ago, trying to quantify that. And we found that the more data you use in fine-tuning your large language model, we were using BERT at the time, it makes substantial cascading improvements on the downstream models as well. So we tried with smaller data sets and increasing them, and also smaller models and increasing them. So the more layers you unfreeze and the more data, high quality data you put at, just your life gets easier without a lot of work. And just this is all unsupervised fine tuning. So it's very cheap. You just really have to have access to good and high quality data. There's some operational challenges when you run such a system with hundreds of models in production. You have to be very careful about metrics. We build very thorough, and we're very diligent about keeping test set, dev sets, and held out sets. We version them and rotate them every 6 months so that we don't overfit. We also make sure that people annotating held out set are different from the people who are annotating the training data. And we have a system that just trains these models automatically, periodically, and then evaluates it. And we have an alerting system that tells us, hey, this model has regressed. And then this takes me to the next point. Okay, it regressed. What can I do? We had to build a lot of machinery around, I need to deploy my model or roll it back to a certain point. Computer scientists and software engineers have solved this for code, but it wasn't as well solved for ML models. So we built our own system that allows us to do that. And then the last critical piece of our infrastructure is whenever you're training such a network of model like the one I showed earlier, you're not, more often than not, you want to train multiple nodes of that graph at the same time because they're interdependent. Sometimes you're focusing on one node and iterating over it, but more common is parts of it. So we had to build a way to allow our ML team to pick which nodes in this graph they want to train on, and then click a button to train all of the network. So then our training system will decide, oh, these ones, I'll just use the latest version because we don't want to retrain it, but these nodes, I'm going to retrain them and then retrain the ones later downstream from them on top of them. So this allows you to kind of like get a holistic view of how your platform operates end to end without having to do like one at a time and waste a lot of time doing that. I'm done with the post-signature part of the presentation. I'm gonna keep the questions till the end, but I promise I'll come back to anything that people are interested in, just so I make sure I cover all my material. So pre-signature, where can we help? We want to help customers with clauses and like generating clauses, editing their contract language, and basically if they have a certain playbook for how they want their contracts to look, automatically do that for them, so they're not redlining manually every contract that they get their hands on. This is something that makes them really fast. I'm going to switch to a demo again. So how does that look? When you're in Lexion, you can easily open a task. So this is part of our pre-signature product, not our repository, where you can just open any draft in our Word plugin. And once you do, you would get this experience where now you have this pane on the sides, and you can review. So you can basically apply your existing rules, and we automatically apply all your rules and help you fix them with just one click. So here I have a bunch of rules that I want to apply to all my contracts that my counterparties are sending me. And now with one click, I can just apply these rules, or I can do it manually. So I'll just show you a live example of that experience. Here's an invoicing clause, and we picked this one because it's easy for non-lawyers to understand. Looks like I'm supposed to pay annually. There's 45 days to pay, and there's some late payment fee if I'm not paying. So I just want the AI to help me change this to quarterly billing, and make payment terms 30 days, and put maximum $100 late payment fee. So just an idea, and I can click generate suggestion. So now the our fine-tuned language model is basically taking this text, my instructions, and applying them. So now it looks like it did a pretty good job. Changed to quarterly, made it 30 days, put a cap. So now I can accept that. Looks like it's good. I'll click replace, and now I have a red line and it's ready. And I can just keep doing that for other clauses. We can also obviously add language. So I can tell my model, hey, you know what? I want some language. Add language to prevent my customer, my vendor from using my logo. And I can click generate. And now I have it. Let me see. Yep, looks pretty good. I don't need to generate a new one. I'm just going to insert it. And now I have that clause. And I can just say this is logo rights. So everybody has seen ChatGPT. This is kind of bringing GPT-like, ChatGPT-like experiences into their flow, integrating with the rest of the system. Because now I can just click save, and it's a new version in Lexion. And I'm done. I don't have to keep copying and pasting, and I don't have to read these contracts in big detail. So I'm going to shift back to my presentation now that we've done the demo, and talk a little bit about what is this as an NLP task. There's an same input, but this time it's not a PDF. It's usually a Word document. And then there is our own fine-tuned prompts that instruct the LLM how to interpret the user prompts. And this is important to get a good output. And then sometimes the user will give us instructions. Sometimes they will give us rules. Sometimes we will give them our own instructions. And the output is a redlined version of a contract that's ready to ship for a counterparty. This is at a high level what's going on under the scenes here. So now what are the challenges? Similar to how I talked about a lot of challenges with NLU. Now I'm going to talk about the challenges we're facing here. Output formatting is a thing. You only realize it when you start like incorporating something like GPT-4 into your product. It's hard to get it to give you a consistent output. If you're using LangChain, for example, it has like a whole section about this problem. How do you actually get parsable output that you can build into another product? I'm showing two very naive examples here. One case, I'm asking the model to place tags on changed parts so I can extract them on the left. On the right, I'm asking it to give me the output in some numbered format. These are very naive. To actually get it to work at scale, like longer text, you have to do a lot more gymnastics to get that to work. But it's a thing that you're going to have, any practitioner will realize very quickly. Inconsistency is also challenging. These decoders can really give you, for the same user, very different outputs. And you can kind of rectify it in different ways. For us, we started by making it clear that these are suggestions, and we made it really easy for you to generate another one if you don't like this one. So you build it in the UX. You can try reducing temperature, and there are other hyperparameters too that will help with that, and it will give you more consistent results, but it will become less creative. And then if it's not doing what you want, it's hard to get it to change. So getting that right, hyperparameter tuning is important. And then you can also try to prompt it with users' history. So if there's certain language that they really liked in the past and they've used, then you can try to put it as part of your prompt engineer prompt, so that you're swaying the model to give you something consistent with that. Next thing, data provenance. It's a big problems with these generative models. They're very good at memorizing and repeating whatever you train them on. So unfortunately, in this new world, we now have to fine tune per customer. We cannot just build one shared model and share it with everybody. Otherwise, it could leak data. Technically, or theoretically, rather, this is a risk in our contract understanding, but these models they spit out like classes or very structured information. So to reverse engineer any of their training data, you need almost infinite access to the model, and probably too much compute. It's kind of like trying to reverse engineering like a cryptographically secure hash function. It's very hard, especially if you have the right guardrails. So it's not an unpractical concern, but it's a very real issue in these models. You can try to alleviate it by rely on prompt engineering wherever you could, instead of fine-tuning, so that you're not actually baking the customer's data into the model. And then you have to, wherever you have to fine-tune, then you have to build the model per customer, at least with the current architectures. Cost and latency are a thing. Cost concerns me less, just because if you're solving a high value enough, a problem that's high value enough, you can still have decent margins. And this will go down as these models become more efficient and have less parameters, and self-hosting might help, things like that. Latency is more annoying. So you have to design your UX such that if you're running the whole contract, it might take minutes. So you want to do it and pre-cache the results so the user sees it once they open it. If you want to build an interactive experience like the one I showed you, then you have to pass chunks of the text. You cannot pass the whole thing. And then you have to decide what are the relevant chunks. Is it just this paragraph? Is it the ones around it? Because there could be a paragraph in a very different part of the part that the customer is working with that's relevant. So you have to find these dependencies and pass them. Otherwise, you're going to get bad outputs. And then if you fine tune prompts, the actual length of the prompt pays into your costs at least in the OpenAI pricing structure. So you would have to, if you're able to reduce the prompt size by fine tuning, then you can do that and save some money. Just some math, like on a typically sized contract, it will cost you something around maybe $1 to $3 to do it. And again, you can squeeze some more out of that, but it's not cheap. It's like 10x or maybe 50x, depending on what you use, more expensive than the OCR. So you can see that the higher in the NLP stack you go, the more costly it gets. Versioning is a thing. I mentioned in first half that we have to version all our models and be able to roll them back. We typically would version the model weights and the model code, like the neural network itself, the featureizing code, etc. Now with GPT and GPT-like models, you also have to version the prompts, because the same prompt will behave differently, not only between 3.5 and 4, but even as you fine-tune the same, like GPT-4 for different customers, the same prompt will give different results. So now prompts are just part of the things that you have to version and build infrastructure for. This is my very last slide, and then I would love to take some questions if there are. We have two systems. I get this question from a lot of people, practitioners, investors, our own board, like, should we just kind of like use one for everything? The answer for now is not yet. We're unable to get even close to the performance of our current models for NLU using LLMs. They're getting better. Like, we've seen a big step function improvement from 3 to 3.5 and then from 3.5 to 4, but still it's not there. And you still have to solve a lot of the problems that we solve, like the header footer issue, the OCR quality. Over time, maybe. Right now, our existing models are outperforming GPT when used in zero-shot or in few-shot configuration. And they're way cheaper, way smaller. They just cost a lot less. So it doesn't make sense to just move that workload to GPT-4. Fine-tuning also GPT-4 is fairly expensive compared to fine-tuning our existing models. I do suspect these things will change. I am excited about the future. It's possible that as these models become more efficient and we prune the parameters and get them to be more specialized, I think there's a path where maybe you need just one foundational model and it can solve all your tasks. It will certainly make operations a lot easier for us and everybody else in the space. So we're monitoring the space closely and running experiments very frequently to just monitor this gap. That's all I had. I'm now going to go through questions. I assume Seth.
Just go through the, this is Seth, just go through the Q&A and you can read the questions out loud. And anyone who wants to ask a question live, if you use the Zoom raise hand feature, then in turn, I will enable you to go on screen to ask your question. Go ahead, Emad.
Thank you, Seth. Okay, so starting from the very top. What accuracy can you reach for terms abstraction, parties, for example, and what had the biggest impact in improving accuracy? Depending on the type of the contract, we work with very diverse sets. Some of them are simpler, like simple commercial agreements will be more complex than very complicated, like back office banking agreements, for example. But I want to say for parties, you can get to 85 to 95% accuracy. Out of the box, just with the model, with like no human in the loop at all. And the biggest impact, it's really a lot of small things. There has been so many, I can't really pinpoint one thing. It's all I mentioned. Like, you have to improve the OCR, you have to use visual cues, you have to find relevant text. When you, even as like if you think about parties, it's not only mentioned at the beginning of the contract. Sometimes it's in the signature block. Sometimes it's hidden in the middle. So how do you kind of like focus the model on this relevant part and not miss it and then extract from within it has been a challenge. But I like for customers or users who are like uploading like simple basic commercial agreements, which is the vast majority, it can be as like accurate as 95% and even higher. For more complicated things, complicated workloads, maybe 85 to 95% would be the ballpark. Next question. How to extract the title? It's mostly positional info from OCR or NLP features. It's both. So positional info is very critical because title often will be in the center and it's going to be bolded in a different font. So you need the position and the styling information as features. But the text itself has a lot of weight. Because titles can be very diverse. It doesn't have to say master service agreement. It could be amendment number 2 to the data processing addendum. And this language can show up in the contract too. So you have to kind of solve it as as both at the same time. And yeah, it works reasonably well. You can try, you have to use semantic embeddings. I don't think you can try to do like, when you say word matches, I assume you mean like specific rules or searching for specific matches. That just doesn't work. It's like once you start introducing rules, you end up with a very high precision, very low recall system. And then you have the pain of having to maintain test sets and making sure they don't regress. So we just shy away from that like rule-based system altogether because it just doesn't scale. Can it also detect if the contract contains an ambiguity? Good question. So in the contract understanding, it could detect like 2 different pieces of structured information. We wouldn't today like flag the conflict for the customer, but the customer will literally see that we extracted 2 things that are non-conflicting and then they have to resolve it. For drafting, it's something I didn't try for like for pre-signature. It's not something we've experimented with. So my honest answer is I'm not sure, but I wouldn't be surprised if you could, at least using an LLM. When you train on weakly labeled data, don't the incorrect labels hurt the optimization of your algorithm? Don't they get stuck during loss optimization as they don't get the correct feedback from time to time? That is true. So this is why on the weakly labeled data, you have to have something that scores your labels. So there are various approaches here. You can have a machine learning system that literally tries to rank your labels, or you could try to introduce some of these labels as features, and then the features, the labeling functions with poor weights will be weeded out. You can also use something like majority voted, so only accept a label if multiple labeling functions agree on it. In our system, we often see that the same label would be produced by 5 or 6 labeling functions, and maybe sometimes like 4 labeling functions agree on some definition and the 5th disagrees. So it's clear that it's not useful and you just drop it. But you're right. The bad labels certainly would hate performance, and you cannot get to like 100% perfect labels in a weak system. So your model has to be a little resilient. You have to try to prune as many of the poor labels as you could with your weak supervision system. And then you also, I think, active learning, where if you have a bad label that made the model learn the wrong thing, and then you have to have like quality gates. So presumably you have some dev sets that will catch that there's a misprediction, or the customer will fix it when it gets wrong. So if this flows back to your active learning system, now your annotation team will be able to say, hey, we got this wrong, and it's actually labeled by this labeling function. Let's actually investigate this labeling function. And we actually have a system that will automatically bubble these up for you. So having bad labeling functions is very expensive. So we favor, when we're suggesting things for annotators to review, we heavily index on bad labeling functions for that reason that you mentioned.
Emad, we have a question from Joaquin. If you want to go on camera and ask your question. Oh, appears he dropped off. Why don't you go ahead with the next question in the Q&A?
Sure thing. So I should go to Hamza's question. Are you worried about unexpected consequences of weak supervision for labeling training data? Are there any such consequences you've already found that you can share? It's the same thing that I mentioned. It can produce bad labels, which can produce bad models. So you just have to have enough checks and balances, enough validation sets to catch these as early as possible, or to have a feedback loop closed with customers so that if it results in bad models, you can correct it quickly. Alina, hey Emad, have you made the BERT model from the BERT Goes to Law School paper public? The model itself, we did not make it public just because it's part of our core IP. The paper itself is public. The experiment is easy to reproduce. And there's now a very popular data set called Atticus, ATTICAS, or US, which is a pretty decent contract data set that I suspect if you just use this and try to fine tune BERT, maybe not BERT, maybe use something more modern. That was a little outdated. That's a little outdated now, but you should be able to achieve something very similar using Atticus plus maybe distilled BERT or something like that.
Let's try again for Joaquin. If you want to go on camera and unmute, you can ask your question. You're good.
Emad, can you hear me?
Yes.
Yes.
Okay. Thank you for the presentation. It's quite interesting. I have a question regarding the prediction of risk given changes in the contract. So if you have clauses that have changed, is it possible to identify or even score risk values? And I'm very interested in that because of other reasons. So we can, connect offline if you're interested in understanding the rationale behind the question.
This is one of the most highly desired features from our customers. They literally want us to flag risk for them. We are building something like what you described right now, but we're making it very clear that that we're not lawyers. This is just something for like a suggestion because we cannot opine on the law. We're not a law firm, at least not yet. And customers will have to kind of like review everything we say, especially when it comes to risk, because they can get into real trouble if they just trust the output of an AI system.
Correct.
But it's something we're working on. I'm happy to chat with you about it.
Yes, please. I have some ideas there, and also existing or pre-existing legal templates that you can compare against. So yes, thank you.
Of course.
Anyone else wants to ask a question live, you can use the raise hand feature. And Emad, why don't you go back to Q&A?
Will do. From Dave, for the fine-tuned LLMs, do you generally have to tune models for each client of Lexion to adapt to their legal document writing preferences? Not really. We're able to do it once. And the thing about like commercial contracts is they're shared. Like every company works with all other companies. So even a single customer's data set has representation from so many others, from their customers and vendors. So it hasn't been an issue that you really have to train on every single customer. Where we need to fine tune per customer is where the customer has a preference. And this is typically more around drafting. If you're asking more about the drafting and like the pre-executions, we do have to do that. And we have to use customer data specifically so that we don't leak information. And because the customer does have a preference. So we try to basically honor their preference in generating this language. Tom, is there a self-hosted enterprise version of such product? If you're talking about the NLP platform itself, we do have a version. We currently don't. It's not a product that we sell like widely, but if you have a use case and this is a high, like you can get value, I would love to talk to you and we can give you access to the system and we can see if there's some synergy there. Are any patterns or unexpected findings in the dimension of the jurisdiction of the contract? Are you currently limiting yourself to contract from the US or using any contract in English? We're doing any contract in English. We're not doing non-English contracts yet, but because of our customer base is very diverse all over the world, we have a lot of customers in Middle East and Europe and Australia and Southeast Asia. So we do work well with English in general. Obviously, we perform slightly worse if it's a contract, an English contract, let's say coming out of Europe, just because, as you said, the language will vary slightly. Hasn't been enough an issue where we decided to stop, but we do add it as a caveat to the customer. And we also have like a extraction score, especially if the contract has multiple language, which is more common. Like if a contract is coming out of Europe, for example, it might be in parts of it might be in French and parts in English or any other language. So we do flag these multi-language contracts in particular and should warn the customer that they should pay more attention because our models might get a little more confused than the average. Can you define what is an input token? So for most of our tasks, it's a word. For some tasks, subwords. And the definition of a token varies between like post-execution or pre-execution. For pre-execution, where we're heavily relying on GPT, it's their definition of a token. So they have a tokenizer that you use and kind of use whatever definition their tokenizer achieves. For our system, we have our own word breaker, which is fine-tuned for our domain. And it's actually a hard problem because let's say in standard English, you can break safely on periods and say that that will work 95% of the time. In contracts, it would often say DocuSmart Inc. periods, and then continue the sentence. So a traditional tokenizer will fail miserably. So we had to fine tune our own tokenizer so that we don't fall over in these cases. What is the LLM? What is the LLM you're using the product? For pre-signature, it is GPT-4. And then we do our own fine-tuning. For pre-signature, we have a variety of models depending on the task. You can think of them as variations of BERT-like models. And then we have our own neural networks on top. So we basically control the layers that run on top of fine-tuned BERT variants. Do you think limiting your data set to things relevant to the application, in this case, contracts, you will always help perform general purpose GPT-like tools? I do think so. I think fine-tuning on a specific case, at least as far as we've seen, holds true. It's hard to assess how this will be in the future, honestly. GPT is, for example, GPT-4 is already doing very well across many domains. I think this gap will get smaller, especially that they're training now on so much data. And it's clear, it's obvious to us from our experiments that a lot of contractual data, for example, got leaked, got trained into the training set of GPT-4. Not clear to us where from. Usually contracts are very heavily guarded. My guess, some public data sets. So I do think these general purpose ones are at a disadvantage versus like when you fine tune on a very specific. This disadvantage seems to be getting smaller the more training data you use for your general purpose model. I don't have any quantified data on how big that gap is. But today, we are beating it. Just like our biggest advantage in beating these models today is that we are fine-tuning on domain-specific language. Going to the next question. Thanks, Emad, for taking time for the webinar. In your opinion, what are the future trends in language translation and the biggest immediate opportunities that you see for GPT for the enterprise space? Language translation is actually something top of mind for me because we plan on expanding to other languages beyond English. Today, we support it for OCR. We still don't support it for the extractions themselves. And I would love to have to rebuild the models n times for every language. It would be amazing if we can use a shared model and do the translation on top. So translate maybe translate all the inputs into English and then run the existing models if they work well enough, or maybe train a single universal model that's language agnostic and then train it once with labels from all languages. I am excited. I do think with GPT-4 and all the work in translation, that might be finally attainable. I didn't work on the problem yet, me or my team. GPT for enterprise, I think there's so many high-value use cases. I think people are sometimes using it where I think there's immediate value and people can build very fast is generative use cases, where you're actually trying to generate text. It's just, this is what it was built for. I see people trying to use it for understanding or other tasks where it does reasonably well, but our experiments show that other approaches work better and cheaper. So I think in the enterprise space, anybody who can come up with a good problem area and a solution where you need to generate text, whether it's content or sales emails or anything that you agree is produced by a highly paid professional, ideally, I think can be transformed with these technologies. Whether you can do that for understanding as well, I think I will point to my last slide where I just said, like, when will the system converge? It's not clear yet. And will they ever? How do you see in the long term, will custom NLP remain any advantage compared to pre-trained? This is a good question. This is actually very existential. I also think about this, and I was just discussing it with my team in a offsite last week. So we have a lot of investment, and a lot of companies have investment in custom NLP. Are these all going to eventually get written off? And are we all going to be using the language model? I mean, there is a world in the extreme where it's just very large LLMs that are just very good. And then all the NLP work is just like, I'm working on these models. So you either are working on an application or you're working on the big model. And this kind of like in between disappears. I think there will always be some need for custom NLP just because people focus on the success. Like if you look at all the ChatGPT articles, people are always like heavily biased and selecting the best cases. Once you actually sit and play with it on a real use case and try to get value, you quickly find the edge cases that don't work. And often these edge cases can be solved with more traditional NLP. So again, today, it's very clear to me that there's still a gap and you still need this expertise. Like, I'll give you a very concrete example. I was trying to get GPT-4 to just give it a contract with the headers and footers and see, like, you know what, we spent all this energy trying to extract them from our other system. Can GPT just like work around it? And I gave it a bunch of examples and I was monitoring performance and it did okay. So it didn't fall off as much as our old system used to, but it still falls off a lot. So then it doesn't fully solve the problem. As they evolve, or maybe as it gets fine-tuned on data sets with headers and footers, where it's told explicitly to ignore them, maybe it will get better, but we're not there yet. I do think anybody who's not any NLP practitioner who is there's also a class of NLP practitioners, it's shrinking, but it exists, that are kind of discrediting this motion and like treating it as somewhat of a fad, or like, no, you'll always kind of need traditional methods. I do encourage these people to take a closer look at them. If you're a skeptic, I do think there's reason to be skeptic, and I don't think these new platforms are perfect, but there's something very real there. It's not all hype. How much time can a law firm save with the help of Lexion? Roughly, so we don't sell to law firms, we sell to enterprise legal teams, and we see as much as 80% time savings for people who are using our AI. I would expect that it will be somewhat similar for law firm, although I don't have concrete data. What tools or processes have you found most useful for monitoring performance of your model and preventing degradation in performance? It's a good one. There's a lot of observability tools out there that are fine-tuned for machine learning workloads specifically. You can look at tools, for example, like Y Labs, which is another AI2 company. But we often have to also build our own stuff. So you have to define your metric. And the metric is very different from, this is the problem with MLOps space. Every ML product, or most ML products, are very different because they have different objectives, and it's not as clear cut. Like when you're writing just traditional software codes, it's more shared. Like everybody hates exceptions. Everybody doesn't want an HTTP 500. So it's easier to define success and failure. Once you get into these ML products, success and failure are harder to define. So we have to build our own measurements, and then we have our own alerting infrastructure. We didn't build the whole thing from scratch. We're heavily using things like AWS CloudWatch and their alarms and so forth. But if you're in the early days, you should look at tools like Y Labs, and then you should also look, there's now a couple of products coming out very recently on observability just for generative AI. There's a company that was recently funded by Sequoia. I don't remember the name now. And there's another one that I can connect you to. It's people I got introduced to, and the products look very interesting. And we're actually going to be experimenting with the product soon for monitoring generative AI models. Can you recommend pre-trained tool library to pre-process a bunch of PDF with tables and graphs, slightly more complex than a contract? this is a hard one. We've spent so much time to do these analysis. We've compared all commercial solutions. We've compared almost all open source solutions. And this is something that we spent a lot of time on. So I can't share specifically what is the best. And also even the best ones require quite a bit of tuning. However, you can get very far using an open source library like Tesseract, just fine-tuned correctly. It works reasonably well. It's not you can beat Tesseract using a commercial solution. And there are multiple ones that you should consider. Just look at all the cloud providers, and depending on your task, probably one will work better than the others. They all have different specializations. Some are focused more on tables, some are focused more on handwriting, some are focused more on foreign languages. So you have to pick and choose. But if you're kind of like in already, if you don't worry about COGS and cost, that would be probably the path I recommended. And these teams are all actively researching and improving these systems. If you are kind of in the early and experimenting, Tesseract is pretty decent. Have you found mechanisms or tools that have helped maintain versioning across all your version artifacts, code, models, training data, prompts, etc.? It's a great question. I'm not sure if this is Dave Moore, but if it is, that's something I think Dave is asking because it's something that we were actively working on together a few years ago. So the model weights is the easiest. The training data, we essentially don't version all the data because it's too much, but we version all the edits. So we have like the original version of training data, and then we basically literally version every single label on top, so that we can always kind of, if something regress, we know how to go back to the last known good version of the training data. There are tools, however, like DVC and similar tools that will version training data for you. It's just too much infrastructure for us to run. Code itself and the models, there are two typical approaches. You can model at the code level. So just every time you create a different version of the network, you can create a new file literally, and then just switch at the file at the class level. Or more practical is to version at the Docker image level. So just once you snap into a version of the code, freeze the Docker image that you produced, and then this is the way that you go back and forth. Prompts, right now is very early, so the easiest thing is just to throw them into a database and then just create an audit log on top of it. But I suspect there will be a lot of tools in the future, just because prompts are very rich, and you don't only want to version them, you want to be able to diff them. They're almost like code. So you need all the tools that you get from source control. And we haven't built something that sophisticated yet, although I suspect we will have to.
Let me just break in for a moment. We've been going on for an hour, and I think you've been handling questions for probably the better part of 20 minutes. We can keep going for a while. I see we still have 12 questions in the Q&A queue, plus a few others. So we'll see what we can get through. But if people have to leave, of course, some people have already left, then that's fine. We will post the recording. So Emad, let's continue with the questions in the Q&A, but I wanted to thank people since we're getting some drop off.
Wonderful. If I didn't get to your question, or if you thought of a new one, my email is my first name, Emad@Lexion.ai. Please drop me a note and we can schedule time or respond offline. Okay. About your application that generates suggestions based on the user's request in plain text, are you using your own generative model, or are you using prompt engineering and call ChatGPT API? We're using GPT-4, not ChatGPT API. At least now, and we are using our own prompt engineering and fine-tuning on top of that. I don't know, eventually we might have to move away, maybe for cost considerations, or maybe for privacy considerations. Every day I'm seeing more news of things like Bloom and Llama, and maybe someday we're going to self-host, but at the point we're getting enough, like we're getting sufficient value out of just using OpenAI's API. Have you also benchmarked some of recent open source LLMs like Alpaca, Vicuna? Not yet. We haven't had that. We're a very small team, by the way. I mean, we're a small company. We've only been around for 4 years, so we have limited R&D resources. I would love to do this kind of benchmarking, but I honestly haven't. And practically, I think I will wait. There's so many amazing practitioners and academicians who will probably do the benchmarking, and I'll just probably read the paper. For us, we try to benchmark our own proprietary systems versus the most popular or the strongest available one outside, just to keep tabs on our IP and moat. For NLP plus computer vision, have you leveraged models like Layout LM, or are you developing your own solutions? Our own solutions today, I'm very familiar with Layout LM. One of the applied scientists on our team is very bullish on it, and it's something that we want to experiment with eventually. But today we're using our own stuff. Layout LM seems to be doing something very similar to what we want to do. So it's a good starting point. How do you see the portion of use cases being solved by generative AI? Do you see traditional NLP model approaching being? I think I already answered that one earlier. Basically, just it's unknown yet. Right now, I'm just gonna, in one sentence, I think right now there's still some need for some traditional NLP, but I think this gap is getting smaller. Whether it's gonna go to zero or not is still out. The jury's still out. BERT only accepts sentences of maximum 512 words. Are you using BERT? We did have to deal with this limitation, and we chunk. 512 words is pretty long, and remember that we almost never pass the whole contract to a single model. We have like a lot of pre-processing to find the relevant parts, and it's uncommon for these relevant parts to be more than 512 words, and if they do, we just do chunking. Do you have any advice for startups using LLMs in Word to text model? I'm not clear on what word to text models mean. So I'll pass on this one. Maybe you can clarify towards the end, and then I'll get back to it. Are there any resources you recommend when getting NLP medical data? No, honestly, I know that Amazon, because they have Comprehend, which is NLP for medical, they probably have some pointers. I would look there. AWS Comprehend for medical, and then I would reach out to companies like Truveta that are kind of advanced, like tech companies that are very deep in the medical space. They probably have a lot of data and are looking for partners who can do something worthwhile with this data. But as of now, I'm not familiar, because with medical data, there's HIPAA, and it's really hard to get access to good data without running into compliance issues. Can you connect with you? Yeah, of course, I'd be happy to. I'm very easy to find. My name is not very common, so just search for my first and last name and you'll find me. Oh, it is you. Cool, Dave. I assume that. Good to hear from you. I'm glad. The problem that, so just for people who don't know, Dave was a member of our team in the early days. We were very sad to lose him. He went on a different adventure, but we've worked on some of these problems that I mentioned today together. Similarly, we also version code at Docker image level. Okay, good. I agree. The source level things is hard. It's good for experimenting. Yeah, like you can have like maybe 2 versions of the code if you're changing them a lot, but at some point it just doesn't scale. Is fine-tuning available for GPT-4? Yes, it is. You have to use their API. It's fairly expensive. So you have to first make a business case for it and make sure that it's going to be give you an ROI before doing it, because you can spend a lot of money doing it. Are any of your non-legal libraries or models in the public domain interested in PDF readers? Unfortunately not. Today they aren't. We do have APIs that we can expose for somebody to use our models as a black box, but we do not publish the models themselves. As a very early stage company, like IP, like we cannot afford to kind of give that much part of our IP. Eventually, maybe as we grow and can have like maybe a set of open source models for the community, we do try to publish a lot of our works. So if you go to the artificial intelligence page on our website, you'll see a lot of our published articles in NeurIPS and KDD and other venues. I think word to text was meant to say speech to text. Oh, I see. I'll be honest and say I'm not an expert in speech recognition. So I will defer on that one. I suspect it would be. If you want to talk about speech to text, I can connect you. I have a lot of friends, both at AI2 and outside, who are working on this task, both text to speech and speech to text, that are doing incredible work, honestly. It's just amazing. Almost as impressive as, or even more impressive than the stuff we're seeing in the news about ChatGPT. So I'm happy to connect you.
So you've gone through an amazing number of questions in the Q&A. We did have a few back in the chat. Let's see, you already answered about alpaca vicuna. I can't quite see a question there. Did you answer challenges when extracting legal clauses? I don't think you did.
No, do you mind repeating the question?
What are the challenges you faced when extracting legal clauses?
I think one of the biggest challenges is that a clause doesn't necessarily have to align to a paragraph. It can be like a set of sentences within a paragraph. It can be multiple paragraphs. It can be part of a sentence. So what really is even the definition of a clause was a very tricky thing for us to do. And then because it kind of it impacts how you model the problem. Is it like a word labeling task? Is it a sentence labeling task? Is it a paragraph? Is it something completely different? Is it a sequence task or not? I think that was one of the biggest issues. Once we got past that, it became a fairly easy, like multi-label, multi-class classification problem.
Okay, let's see what else. People might look at the chat. Various attendees share their LinkedIn and other contact information, but I think that's it for questions. And we've gone a good amount of time. So I think we'll wrap up there. You got some great questions there, Emad, some great engagement, and it was a really interesting talk. So I'm glad to have come up to speed on what you're doing. So thanks, Emad Elwany, for presenting today on Lexion and legal NLP and contracts and all that kind of stuff. As I mentioned earlier, we will have the presentations posted. I will have them posted to nlpxing.com within a few hours. Just take some processing time. And if you'd like to give a presentation, anyone at a future NLP meetup, that can be online or it can be in-person hybrid. If the in-person is for me in Washington, DC, New York, or Boston, send me a note, message me through the LinkedIn platform. So thank you everyone for joining us. And thank you once again, Emad, for speaking, and see you all next time, I hope.
Thanks, Seth. Thanks everybody. I really enjoyed the discussion.